small step for man, one giant leap for mankind.
Although I wasn't born when this happened, we all have heard that exact moment and that exact phrase from someone. But as a little boy, and even now, I never truly understood the science and the smarts behind that one phrase. And now, it's your lucky day to learn it all. First, we'll start with the wonderful moment that a rocket is lifting off into the air and right out of this world. It's astonishing how fast the rocket goes to break through the atmosphere. But of course, in physics, in order to reach a speed, there needs to be some sort of acceleration to move this massive rocket from rest. With the sheer force of the thrusters, the rocket's acceleration reaches 101.5 kilometers per hour squared. To put in perspective, that is way faster than the fastest car in the world could ever accelerate. You can see the immense power that a rocket needs in order to break free into outer space. And believe it or not, there's a certain speed it needs to actually make it that far. This is called the escape speed. What that is the speed in which an object, or the rocket in this case, needs to escape the gravitational pull of the Earth. Using a magic equation, obviously, we conclude that the rocket needs to be at a speed of 8,549.3 kilometers per hour in order to escape the Earth's gravitational pull. Now that's truly a crazy speed, and that's about 2 times faster than the fastest jet in the world. Think about how you would feel going that fast. What usually happens next is the rocket will go to the International Space Station. This space station orbits our Earth constantly and never stops. As the physics geniuses that we truly are, and learning from some incredible teachers, we decided to look further into the orbiting of the International Space Station. First off, we found the exact radius that the space station orbits, which is truly incredible. It orbits at a radius of 6,692,868 meters over the surface of the Earth. That's about 746 Mount Everest stacked on top of each other. Now remember, that's one of the tallest mountains in the world. We actually found that the space station travels at 7,823.2 meters per second all the time around the Earth, which is 28,163.52 kilometers per hour. Imagine driving that speed on a highway. Now that's fast. Another example is the Apollo 11. The Apollo 11 was forced to orbit around the moon in order to save fuel. This saves fuel because when they orbit, they're using gravitational pull of the moon to slingshot them around and turn them around without using additional fuel. As it orbited, a smaller shuttle went down to the moon and landed as the spacecraft continued to orbit. Now in order to get back to the spacecraft, they need to know the speed of the orbit to have the proper trajectory, or they could be lost in space forever. And Apollo 11 would never even have been a thing. Now using information from NASA, we found that Apollo 11 actually orbited at a speed of 6,045.9 kilometers per hour. In relation to orbiting, binding energy is another physics application that can be used throughout space exploration. Since you're only a young physics mind, you're probably thinking, what the heck is binding energy? Here's your fourth new learning of the day. Binding energy is the energy required for an object to escape the orbit of a planetary body. In space, this helps them understand the slingshot around planets to conserve fuel and allows them to safely escape the orbit when they're facing proper direction they want to be in. Probably one of the most important parts of space exploration is the landing. Spoiler alert, but as much as you should love the movie Interstellar and Matthew McConaughey, the most important part is getting the astronauts home safely and not lost in another galaxy. What is important to know for safe landing is the terminal velocity of the shuttle falling to the Earth's surface. For your next fun fact, terminal velocity is when the net force becomes zero and the object is no longer accelerating, therefore not getting any faster. The shuttle falls at immense speed and goes so fast that it actually catches fire in air. It will fall initially at 828.4 kilometers per hour, and this will be its terminal velocity falling down. This is where 4 parachutes really come in handy, because if you're hitting the ground that fast, there's no way you're going to live. When these parachutes are released, it actually slows the shuttle down to 287.6 kilometers per hour. See, we're getting closer, but not great. You're probably thinking, these parachutes are some sort of witchcraft, but I promise, the physics is the reason for this magic. Finally, For a nice safe landing, the parachutes will bring the shuttle down to a terminal velocity of 5.5 kilometers per hour. And now, the astronauts will really actually be able to live and land safely. Another aspect that isn't directly related to space exploration is the theory of relativity. Albert Einstein created his theory of relativity, which explains how objects interact in the universe. The main point of relativity that must be considered for space travel is that time can be distorted just like space. All mass that exists will bend space-time, creating a gravity field. Now there's your dose of physics for the day. And honestly, I love teaching the physics in space exploration. I wanted to keep teaching you more, but I just couldn't do that. Now, I'm hoping that you come into here really wanting to explore the space for yourself. Now go out there, get in a rocket, join NASA, go find the moon, go find Mars, go find us another planet to live on when this planet dies. And on behalf of all the people that were involved in this video and all the research done, we would like to say thank you. Thank you for listening, and we hope you become the greatest astronaut in the world.